So here's a thought. What if I told you we've been launching satellites the same way we launched the first one, Sputnik 1, way back in 1957? I mean, sure, shinier rockets, cooler computers, Elon Musk memes, but at its core, still the same idea. Build a giant, insanely complex rocket, use it once, throw it away. That's like building a luxury jumbo jet just to fly to Mumbai once, then lighting it on fire and walking home. And yet, we did this for decades. Why? Because physics is a bully. To get to space, you have to reach escape velocity. That's 11.2 kilometers per second. You can't cheat that. You either go fast or go nowhere. So we build rockets. Not tiny rockets, not happy birthday rockets. We're talking controlled skyscraper-sized explosions wrapped in science. Here's the tragedy, though. Most of that fire and fury isn't even for your satellite. It's for lifting itself out of Earth's atmosphere. That's right. About 85% of a rocket's weight is just fuel. And guess what? It's burning most of that fuel just to push air out of the way. Earth's atmosphere, that beautiful blue dome we breathe in, becomes a nightmare at launch. Which is why we needed a reset. Not just an upgrade, a rethink. Cut to 21st century. And the question quietly emerges in a SpaceX meeting room, probably near a Red Bull fridge. Hey, what if our rockets could, land themselves? Pause. Silence. Awkward cough. And someone from accounting whispers, and we use them again? Boom. The reusable era begins. SpaceX's Falcon 9 Block 5 is about 75% reusable. The booster, that big main chunk, literally flies itself home like a sci-fi boss, lands vertically on a drone ship, gets cleaned up, refueled, and poof, flies again in a few days. You know what makes this possible? Grid fins, giant titanium paddles that steer the booster back through the atmosphere. They look like medieval torture devices, but they're pure genius. They help the rocket do a mid-air pirouette and land backward. It's not just cool, it's efficient. By the sixth reuse, you're saving up to 50% of launch costs. This isn't just space stuff anymore, it's infrastructure. Meanwhile, Blue Origin is working on its BE-4 engine, and this is not just any engine. This baby runs on LNG, or liquefied natural gas, and liquid oxygen. It's called a methalox engine. And unlike traditional rockets, the BE-4 uses oxygen-rich stage combustion. Sounds fancy? It is. What it means, cleaner burn, more efficiency, less gunk, which makes the engine reusable with minimal maintenance. Plus, the fuel tanks pressurize themselves. No helium tanks needed. Less complexity, less weight, more awesomeness. New Glenn, Blue Origin's mega rocket, is aiming for 25 reuses per booster. That's not a rocket. That's a flying freight truck with a genius engineering degree. But now, let's go weird. Stratolaunch. What if you launched a rocket from a plane? No, not a small Cessna. I'm talking 117-meter wingspan, 6-engine monster made from parts of 2 Boeing 747s. Nickname? Rock. It carries a rocket under its belly, flies up to 35,000 feet, then yeet, drops the rocket midair where it ignites and flies to space. Why does this matter? Because most of the atmosphere's drag exists below 10 kilometers. By launching above that, you save fuel. You skip weather delays, you launch anywhere. It's like Uber for rockets. And then there's spin launch. Now we're talking cartoon physics meets NASA dreams. Forget fire, forget fuel. Spin launch wants to spin your satellite inside a giant vacuum centrifuge at 5,000 miles per hour and then just let it go. Yes, like throwing a rock with a string in your backyard. But instead of a backyard, it's a multi-million-dollar electromagnetic slingshot. And instead of a rock, it's a 200-kilogram satellite pod, experiencing up to 10,000 Gs of force. Now, to be fair, your iPhone won't survive that. Not even your smartwatch. But custom-made, robust hardware might just make it. The pod exits the centrifuge, soars up to 60 kilometers altitude, and then uses a tiny rocket to finish the orbital boost. No first stage, no booster, just pure kinetic madness. What do all these innovations have in common? They represent a new era, not just of technology, but of thinking. SpaceX said, what if rockets were reusable like airplanes? Blue Origin said, what if the engine itself could be efficient, clean, and fly 25 times? Stratolon said, why not launch from the sky instead of the ground? SpinLaunch said, who needs fuel when we've got physics? And together, they're reshaping how we think about reaching space. Here's the emotional bit. We're no longer in the age of only governments go to space. We're in the age of garage engineers building CubeSats and college teams testing rocket parts. The technology is becoming cheaper, the launches are becoming faster. And one day, soon, you might see daily launches on your newsfeed and not even blink. But remember, each of these technologies began with an idea. A stupid sounding, what if we spun it like a sling idea? And someone believed in it long enough to test the physics. That's the real power of science. Not the hardware, not the launch pad, but the audacity to ask, what if the rules aren't rules after all?
This is your Edutainer. Intense learning, crazy vibes, brilliant results. Subscribe for more edutainment. We've got more crazy stories coming soon. Over and out.